Hello. Previous class, we have taken the example of Huffman coding for moving the composite bit as low as possible. So in this case, I am taking an example, whereas I am moving the composite bit as high as possible. So let me have, you can see the problem. You have 6 message bits with the probabilities I have written in the table. And we are supposed to construct a binary code by using Huffman encoding procedure, and considering the composite bit should be considered as high as possible. So first thing is I have to arrange the probabilities in decreasing order, since the given problem is already in the decreasing order of probabilities. I have written as it is. Next step is I have to keep on reducing the number of probabilities by adding last two probabilities and placing the composite bit as high as possible. So first thing is I will be adding these two probabilities. So when I add these two probabilities 0.05, 0.05, I'll get 0.1. So I have three options. I can place the 0 point addition of this value. I can place it here. Always the probability should be decreasing order. I cannot place it here because it is lesser than 0.4 and 0.2. So I can place it here, 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 here. So 4 options are there, but they have given you are supposed to place as high as possible. So whenever I am placing as high as possible, I will place this bit, this 0.4 is written as it is, 0.2 is written as it is. So this 0.1, since I have given the priority to place as high as possible, so I will place it here, 0.1, and this 1 is moved here. This is 0.1. This probability is moved here, 0.1, and this is moved here. So it is 0.1. Okay. So next step is I will be adding these two probabilities. I am getting 0.1 plus 0.1, I'll get 0.2. So I cannot place it here, 0.4. I have two options. I will be placing here and here. Since it is as high as possible, I will be placing in this position. So this 0.2 will be shifted here. This 0.1 will be shifted here. This 0.1 will be shifted here. Next, once again, I will add these two probabilities, 0.1 and 0.1. I'll get 0.2. So as high as possible, I will place it here. This is 0.4. This is 0.2. And here, once again, this 0.2 will be shifted here. This 0.2 will be shifted here. Next, once again, I will add 0.2, 0.4. 0.2, I'll get 0.4. So I will be placing it in first position. So it is 0.4. This 0.4 will be moved below this 0.4. This 0.2 will be moved here. So here it is 0.2. Next, when I add these two, I will get 0.6. It is of highest probability. So I will place 0.6 here. This 0.4 is moved here. So it is 0.4. Okay, this is the second step. That means I will keep on decreasing the number of probabilities. Now, so these are all probabilities. This is also probabilities. This is also probability. This is also probability. New set of probabilities I'm getting here. Now, I will get the code in this direction. Now, I will get the code. So first, I will be assigning code as 0, 1. I'll write the code. So I will take it as 0, 1. Here also for all combined values, I will take it as 0, 1. Here also I'll take 0, 1. Here also 0, 1. Whatever I am writing in blue color is nothing but your codes. So 0, 1. So now what to do? This 0.6 is given by the combination is driven. I mean, we got 0.6 by combining 0.4 and 0.2. What is the code word for 0.6? 0. So I will be writing the zeros here for these two values. 0.4 is having the code 1. So it will carry the same probability. Similarly, this 0.4, 0.2 and 0.2 is combined and given to 0.4. So what is the probability of 0.4? 1. That 1 is given to these two probabilities. So next, this 0.2 is having the probability 0, 1. So it will be having same probability. 0.4 is having the probability 0, 0. So this probability will retain here. Okay. So next is this 0.1 combined and given to 0.2. What is the probability of 0.2? 0, 1. This 0, 1 will be assigned to these two values 0, 1, 0, 1. So now this 0.2 is having the probability 1, 1. So that 1, 1 will be assigned here. This 0.2 is having the probability 1, 0. So 1, 0 is assigned here. Next 0.4. It is having the same probability as 0, 0 because it is in its original position only. So next 0.1 and 0.1 is combined and given as 0.2. The probability of 0.2 is 1, 0. That 1, 0 is assigned here for both the values. So for 0.1 probability is 0, 1, 1. So it is 0, 1, 1. For 0.1 it is 0, 1, 0. For 0.2 it is 1, 1. So for 0.4 the values are 0. Next 0.0505 combined and have the value 0.1. The probability of 0.1 is 0, 1, 0. So it is 0, 1, 0. So it is 0, 1, 0 for both the values. For 0.1 the value assigned is 1, 0, 0. For this 0.100 here I am having 0, 1, 1. This value is having the same probabilities and this is also having the same probability. So this is the final code. So this is the final code values for Huffman coding. So these are the symbols, probabilities and the final code. So 0.4 is having the code 0, 0. 0.2 is having 1, 1. 0.1 is having 0, 1, 1. So next is 1, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1. This is how we can get the code by using Huffman encoding procedure. I hope you have understood. Thank you.